Okay, this is spectra is provided by one of our students, and we have to elucidate and we have to find the number of carbons in this compound. So, first of all, before moving to the spectra, we have to see the range, we have to memorize, we have to understand the ranges of different carbon peaks. First of all, you see here, I have drawn here 0 to 50 and 50 to 100 and 100 to 150 and 150 to 220. These I have written here over ranges. First of all, you see here from 0 to 50, here will be like CH3. This carbon peak or CH2 or CH peak will appear on in this range, like you see. You see 0 to 50, CH, CH3 and CH2. This is the area of the peaks of this carbon. And between 50 to 100, there was region of carbon triple bond, carbon and C single bonded with oxygen. Mean any methoxy group or any of the carbon which is attached to the oxygen, that will appear between 50 to 100. And around about 50, there is possibility of appearance of carbon nitrogen, carbon chlorine and carbon bromine. This bond will appear at this 50 position, at 50 ppm. This is the chemical shift. This is chemical shift. This is the range of chemical shifts on which the signals will appear. And again, you see between 100 to 150, this benzene, this aromatic part, like this benzene double bonded, this region, or you can see any of the double bonded carbons will appear between 100 to 150. Different ranges depends upon the chemical shifts. Only you see the range between 100 and 150 will be this type of carbons will appear in this range. And at about 220, the carbonyl peak will appear in this region. It depends. So before moving to the carbon-13 NMR spectra, you have to keep in your mind these chemical shifts, because without understanding the range or the region, you cannot move ahead. You cannot understand the spectra of any of the compound which will interpret the carbon-13. So you see here, dear student, you understand this. I had already told you, if you see on this peak, this is round about 50 or something, it would be around about 50. So this peak would be, obviously, I had already told you, if you have keep in your mind, see here, this is CH2, CH3 or CH, it would be the peak. And the compound that we have to justify, that already we know that compound here, we draw that compound. I show you that compound is see here, this is aromatic part, this is aromatic part, and this is attached to OH, and this is attached to CH3, and then okay, fine. This is our compound. We have to identify, we have to compare all the peaks of carbon-13 in this spectra. Like see here, you have in front of your eyes, this is compound. You see here, this is peak, and this peak is of You can see here, this is CH3. This peak will appear here, CH3. Okay, next we move for the next peak. Next peak, I had already told you, if you memorize the ranges, then 50 to 100, this is the range of single bond O and this carbon triple bond, and this range you have to memorize this range 100 to 150. This range is for aromatic or carbon doubly bonded carbon. So according to the structure, we have this structure. Carbon double bond carbon, and this is carboxyl, and so this region and this region will appear between 100 to 100 to 150. So according to this spectra, if you have compounds like this one, I can draw over here this compound, so it is more easy for me to teach you. Like you have this compound, you have okay, so see here carefully. This CH3 peak is at between 50, 0 to 50. So this carbon peak is of CH3. And next peak, this next peak will be the carbon, this next peak. You can see, mark it as peak 1. This is peak 2. This peak 1 is of this carbon which is adjacent to oxygen. This carbon can be called as 1. So this peak will be 1. Like you see here, this peak will appear at of this carbon. Next you see further there are two peaks which are very close together. These two peaks are actually of this carbon, and this carbon. These are two peaks. So actually we can just determine the number of carbons. Number of carbons can only be identified by using carbon-13 NMR. You see here these two peaks of these two carbons, like you see here, this is 3, this is 4, and this is 3 and 4. These two peaks are appearing over here. And now so we have justified that one is methyl, which is present over here, and these are two carbon. This carbon is 1. This is the first peak, which is very this is very close, and the next there are two carbons and 1, that is two peaks are appearing over here. And the next carbon which is adjacent, which is meta position to the hydroxyl. You see that this position and this position, this is meta position. This is meta position to OH. This meta carbon is appearing at, you can draw it, you can write it as 5, and this carbon peak is 5. So this carbon peak is 5. Okay, fine. Next we move for the next carbon. Next carbon is because we are going to the downfield, so this carbon is 5 at meta position to, and this carbon that is para to OH, that is nominated as 6, and this peak is 6. This peak is 6. And then we move to the next carbon, and next carbon is this is 7, and this is called peak number 7 will appear at this carbon. So this peak is also, this carbon is also identified as, which has already nominated as 4 and 5 and 6. All peaks are identified, and this is 1 is pending and 1 are 2 positions. This last carbon, I already told you, between 200 to 250 to 220, 200 to 220, the carbonyl peak will appear, and this is carbonyl, and this will be you can say this is C double bond O peak. This is. And so there are 2 peaks which are left over here. These are 2 peaks. You have to memorize these 2 peaks. These 2 peaks, the lower peak, this lower peak is of this carbon, and you see that this is 8 and this is also 8 and this is 9, and this peak will appear at 9. So according to the given data, we have just identified all the peaks in the given NMR spectra. You can understand this very easily. There is no issue. All the peaks I have identified, and you can draw it, the carbon 13 structure of the organic compound. Thank you very much. If you need any question, you can ask me. I will further elaborate all the peaks according to their position. Actually, the main criteria I already had told you. You have to memorize, you have to understand the basic ranges of the chemical shifts of NMR, carbon 13 NMR. If you know all about the carbon 13 ranges, then you can understand the exact range and exact positions of the carbon 13 spectra. And carbon 13, this aromatic range, I cannot be exactly find where is this position. Obviously you have to there are various other techniques which tell us about their further explanations to the techniques, more according to which proton is attached to which carbon, and which carbon is attached to which proton. This is just understand by HSQC, QSG and HMBC. But from here, carbon 13 NMR, we can just only understand the number of carbons we have just shown over here, and further the carbons, this is quaternary carbon, or this is methyl carbon. This can be shown from depth, and this is the only simple carbon 13 NMR. And so we have all identified their positions, and all the structure is explained over here. Thank you very much.